Welcome all. Our today's topic is constructive cost model. It's an important topic from the exam point of view, or whatever we have learned, whatever we have seen in the previous lectures related to the estimation. This model is most precise and well accepted model. Okay, this is known by the name of COCOMO, and the full form of is Constructive Cost Model. It was first published by Dr. Barry Boham in 1981. The multiple choice questions would be made from here. Okay, the COCOMO model calculates the and it has the ability to estimate the time, effort, cost, and quality. Whatever models we have seen in the previous lecture, they are calculated the simple effort. Okay, but this model have the ability to calculate time, cost, and quality with the effort as well. Okay, by this facility we can say that it can predict the performance of a software project in advance, and we have discussed about this that we are very curious to know about the progress, about the time, cost analysis of the project in advance. So this kind of information this model will provide us. This model estimates cost using one of the following different development mode. Here we have to know that it has suggest three different development modes in this model, namely organic, semi-detached, and embedded. These are three different types of modes, and basically these modes are, you can think about it like, these are the categories of softwares. Categories of softwares, as different softwares fall under these three categories. As the organic mode says, uh, the range of the software not more than 50 kdsi. Kdsi, 1000 delivered source instructions. Okay, so the organic mode will take the very small type of software projects. It have its characteristic like, it will develop a software in a highly familiar and in-house environment, so there should not be any complexity. The softwares will be simple under this category. The next mode is semi-detached. In semi-detached mode, the range of source code will extend to the 300 kdsis. Okay, and we can say it as an intermediate stage between organic and embedded modes. The team members are a mix of experienced and inexperienced staff. Here, in organic mode, the team members are experienced. Okay. Now our next mode is embedded. Embedded mode have not any limit of source code, the length, the size of the software would be very large, and the type of the software would more complex. Here we have some examples like electronic fund transfer, railway reservation, and other type of softwares are fall under the category of embedded softwares. It have an embedded software project has a high level of complexity, as we have discussed, and require a large size experienced team, and is coupled with complex hardware. So all the complex softwares, or we can say all the large sized software, fall under the category of embedded mode. Here, if we want to learn these three modes in one view, then by this table we can learn these. By this table you can see in first column we have our three different modes: organic, semi-detached, and embedded. And here are the project characteristics. We have divided these characteristics in some columns like size, innovation, deadline, constraints, development, environment. So as we have discussed, organic mode contains small projects, semi-detached contains medium sized project, and embedded take under the large size projects. Here innovation, inorganic, little, medium, and greater. From this table you can get a view about these three modes without without much reading and without much wasting your time. Okay, so let's move ahead. Bohem proposed three levels of the model. As we have three modes of softwares, another we have three levels, namely basic COCOMO, intermediate COCOMO, and advanced COCOMO. Basic, intermediate, and advanced or detailed COCOMO. We will start from our very first, that is basic COCOMO. The basic COCOMO applies the parameterized equations without much detailed considerations of project characteristics. Here in this mode we will not take into consideration the project characteristics. We have some equations and we will simply calculate by these formulas. The basic model is used for quick and rough cost calculation for the software project. As the word quick and rough, if we want a quick and rough estimation about any project, then we can use the basic COCOMO. It calculates effort, time, and number of people required to use in projects, and it uses KLOC, namely kilo line of code. Here we have some formulas to calculate our effort. We will denote effort with E. We can calculate effort E equal to A into KLOC to the power B, and this will produce the result in person month. If we want to calculate time, time will be calculated by 2.5 into e to the power c, and this will produce the result in months. And if we want to know the people required for our project, then we will divide our effort by the time. Here these a, b and c are constants, and here is the value of these three constants for every project type, or we can say for every mode. We have different value of these three constants. As for organic, we can take an example of a. For organic, this is 2.4. For semi detached, the value of a is 3.0, and for embedded, this will be 3.6. For b and c, these are changed. Okay, by this equation you can see and you can learn these different values. Most probably these constants values could be provided in the question, but if it is not provided in the question, then you have to memorize these. Let's take an example. Suppose a project, this is an example how the example will be asked and will be appear in your question paper. This is an example. Suppose a project was estimated to be made 400 KLOC. Let's calculate the effort, time, and number of people required while considering the project is organic type. This will be mentioned in our question, that what is the type of project. Here it is clearly mentioned that our project is organic type, so we will take the values from organic. These values of ABC will be taken. So let's solve the example. For E, we have formula A into KLOC to the power B. For organic type, we have the value of A is 2.4. We have put the value KLOC from the question, that is 400, and the value of B is 1.05. And when we will calculate these, we get 1295.31 person months. These are the total effort for the project. Okay, now if we want to calculate the time, time will be 2.5 into e to the power c. 2.5 into e, we have calculated e. We directly put the value of e here, and for organic type, the value of c is 0.38. We can check it in the table as well. This value is 0.38. By putting these values, we will get our answer, that is 38.07 months. Okay, and people required, we will divide the E by the time. Here this is the value of E, this is the value of T, and we will get the final people required in person, that is 34 people we required to complete this project. Okay, clear? Let's move ahead towards our intermediate model. The intermediate COCOMO model computes software development efforts as a function of program size and a set of 15 cost drivers that include subjective assessments of product, hardware, personnel, and project attributes. Here we have the same equations to calculate our effort, time, and persons, but we have given a set of 15 cost drivers. This is the extra things which will associated with the intermediate model, and these 15 cost drivers are rated on a scale of very low to very high, and this is the every these every cost driver have different values. Okay, most probably the values of these cost drivers will be given in the question. One more change in intermediate model, that is we have an another function, that is effort adjustment factor. If we see, this is our basic type equation, but here we have multiply by EAF, effort adjustment factor. This is the new thing which we have add in intermediate type of model. The time is equation is same, and people equation is same. So let's check the table of these constants. The values will be different from basic model. Okay, if this is mentioned in a question that we have to solve the question in intermediate model, then we will use these values. Okay, here we have these 15 cost drivers, that is product attributes that are required software reliability, extent, size of the application database, the complexity of the product, and here are the values. These are the values for every cost drivers. This will vary from very low to extra high. Okay, most probably these values will be given in the question. We have to simply put these values and get our answer. The hardware attributes, that is runtime performance constraints, memory constraints, the volatility of the virtual machine environment, required turnabout time. Now for all these we have value table. We can take our desired value from these tables. Other attributes are personal attributes, that is analyst capability, software engineering capability, application experience, virtual machine experience, programming language experience. And again, we have different values from very low to very high for every course driver. For project attribute, we have use of software tools, application of software engineering methods, required development schedule. And for these another, we have different values. Here the effort adjustment factor is calculated by multiplying the parameter value of different cost driver attributes. Ideally, the value is 1. It means when we will calculate our effort adjustment factor or EAF, then we will calculate it by multiplying the parameter value of different cost driver attributes. This thing will be clear from a question. Let's take a question. Here we have given, suppose we have a project was estimated to be made in 400 kilo line of code, and we have to calculate effort, time, number of people required, and the given is organic type. The project is of organic type and has a nominal complexity. And here there is one another thing, the developer has a high virtual machine experience. Okay, so developer has a high virtual machine parameter. The high virtual machine parameter value of developer is 0.09. We can check it in the table as well, that is personal attributes, the virtual machine experience, that is here is the value 0.09. Okay, because it is mentioned in the question that a programmer have a high experience, so we have take the high value. From here, let's come to our question. Now we have our effort adjustment factor. We will put all the constant, all the variables, and we can easily find the answers. Clear? You can solve it by yourself. Try to solve these. If you get any difficulty, then take the help from here. Here the question is already solved. Now come to our last mode, and that detailed or advanced COCOMO. The advanced COCOMO model computes effort as a function of program size and a set of cost driver weighted according to each phase of the software life cycle. Advanced model applies the intermediate model at the component level, and then a phase based approach is used to consolidate the estimate. we have to keep in our mind that a phase based approach is used to consolidate the estimate. This is the main line of this. A phase based approach is used. The phases used in detailed COCOMO model are, here are some phases that are requirement planning and product phase, design phase, detailed design phase, code and unit test, integration and test. These are the different phases described in the detailed and advanced COCOMO. So by this, COCOMO model is good rough estimation. Here Dr. Boham says that it provide a good but rough estimation. This is not accurate estimation but provide a rough estimation of the cost of the project and the time taken to complete it. Still, it has some limitations as it ignores the factors like customer skills and knowledge. We have learned and we have seen many factors, many cost drivers, but we have not seen any ability or anything about customer skill and knowledge. Okay, so these factors can affect the progress and the success of a project. Moreover, in real life, things may not work out according to the model, and the project may take more time than the estimated time and effort affect the project. But as it has said earlier that it will provide a good but rough idea. Okay, so this is all done in this lecture. I hope you have learned many things. We have solved questions, we have seen many tables, values in this lecture. So prepare your good quality notes with the help of these lecture and be in learning mode always.